Hello dear students, in today's lecture we will discuss dehydration of alcohol. Now what is the meaning of dehydration? Dehydration means removal of water, means during dehydration of alcohol, elimination of water will occur. Now for dehydration reaction we have required a reagent. So now alcohol from two neighbor carbon atom, from one carbon atom hydrogen and from neighbor carbon atom hydroxyl group will eliminate, and as a result of dehydration of alcohol we get alkene and water molecule will eliminate. So dehydration of alcohol giving us a alkene. Now this dehydration reaction carried out by using a sulfuric acid as a concentrated sulfuric acid we can use, or we can use a phosphoric acid. Up to 85% of phosphoric acid can be used as a catalyst, and temperature required in different range. It may be 373 to 473 Kelvin temperature. Now same type of dehydration reaction can be carried out. Instead of this phosphoric acid or sulfuric acid, one can use a alumina. And you know that formula of alumina. Alumina is nothing but aluminium oxide Al2O3, or by using a anhydrous zinc chloride. So dehydration of alcohol can be carried out by using a phosphoric acid or sulfuric acid. अब आपको एक सोचना भी है कि क्यों हम डिफरेंट हाइड्रोक्लोरिक एसिड और नाइट्रिक एसिड यूज नहीं कर सकते हैं. वो मैकेनिज्म एक्सप्लेन करने के टाइम पे मैं आपको बताऊंगा, लेकिन आपको सोचना है why we cannot use other acid. Temperature we are using 373 to 473 Kelvin and we get an alkene. Now same type of product we can get by using a catalyst alumina, or we can use anhydrous zinc chloride. Now suppose we have a primary alcohol. Primary alcohol, suppose I have taken a ethanol CH3CH2OH. Now ethanol dehydration is carried out by using this catalyst. So ethanol is a primary alcohol, then we have to use a 443 Kelvin temperature will be used, and by using a concentrated sulfuric acid, we have to use a concentrated sulfuric acid as a catalyst. Now dehydration reaction occur from this carbon atom OH and from neighbor carbon atom H will remove. We will study how this removal occur in a mechanism, and as a result we get a alkene. This alkene is known as a ethene. So dehydration of primary alcohol we have required a 443 Kelvin temperature. Now suppose dehydration reaction of the secondary alcohol. Here I have taken propane 2-ol as a secondary alcohol. So this propane 2-ol. This propane 2-ol is secondary alcohol. Now dehydration reaction is carried out by using a 85% of phosphoric acid, and temperature we are using 440 Kelvin. Now dehydration reaction occur in this way. Hydroxyl group from here, and now hydrogen from any one carbon atom can eliminate. Product will be sent. So as a result we get this structure CH3 CH double bond CH2, and this is known as a prop 1 in, and byproduct will be water molecules. So you can conclude that as compared to primary alcohol, dehydration of secondary alcohol is easy. And now for tertiary alcohol, suppose I have taken this 2-methyl propane 2-ol as a tertiary alcohol. Now this is 2-methyl propane 2-ol. 2-methyl propane 2-ol is taken. Now by using a 20% phosphoric acid and at 358 Kelvin temperature, now dehydration reaction occur. OH from this carbon atom and H from any carbon atom remove, we get same product. So as a result of this, suppose I assume that hydrogen removed from this carbon atom, then we get this type of product as a alkene, and name of this alkene is 1, 2 and 3. This is a 2-methyl this we get 2-methyl prop 1-ene. So this 2-methyl prop 1-ene will be obtained. So from reaction 1, 2 and 3, we can conclude that dehydration reaction of tertiary alcohol is easy as compared to secondary, and secondary alcohol is easy as compared to primary. It means tertiary alcohol dehydration reaction occurs at a low temperature and in a normal conditions as compared to secondary and primary. So we can write that tertiary alcohol, for dehydration of alcohol, we can write this thing for a dehydration of alcohol. Tertiary alcohol can be easily reduced dehydrated as compared to secondary, and secondary can easily dehydrated as compared to primary alcohol. Now question will arise, how this dehydration occurs or take place. Then in order to understand, we have to study about a mechanism of dehydration reactions. Now step 1 of this mechanism, first protonation of alcohol. So alcohol protonation will occur, protonation of alcohol. Now here we have this alcohol. Suppose as alcohol I have taken a primary alcohol, or it is known as a ethanol. Now in first step it undergo protonation. So it is a very fast step. Our medium is acidic. In acidic medium, this oxygen having a non-bonding electron pair, and it donate to H, and as a result we get this type of structure. Now here one electron pair given by oxygen, so oxygen having a positive charge and now only one electron pair. So this thing is known as protonated alcohol. So in first step we get protonated alcohol. Now in second step, formation of carbocation. Second step is nothing but a formation of carbocation. Now from this protonated alcohol, water molecule will eliminate. So just I will write it here, CH2OH2. Now here oxygen with positive charge is unstable. So here carbon oxygen bond will break. Electron of this bond will be taken by oxygen, and as a result we get a carbocation. So here in this step carbocation formation occur. So this will be a slow step, and because of this slow step it is the rate determination step. Reaction of this dehydration rate will be determined by this step, formation of carbocation. Now in step 3, formation of alkene will occur. Now from this carbocation, alkene will obtain. So now here carbon having this carbon of neighbor or neighbor carbon atom of this carbocation will give up it hydrogen atom. So out of this 3, any one hydrogen will give electron. It will eliminate, so this bond, double bond form between this carbon and carbon. This hydrogen will go without electron, and H plus ion loss occur, and this electron will be taken by this carbon, and carbon-carbon double bond formation occur. So as a result, we get CH2 double bond CH2 means here alkene, ethene occurs. So once again, reaction occur in a three step of mechanism. In first step, first in the acidic medium, protonation of alcohol will take place. So we get protonated alcohol, formation of protonated alcohol. Here oxygen having a 2 non-bonding electron pair, it give to H plus, and it gives us protonated alcohol. This is a very fast step. In second step, formation of carbocation. Now in protonated alcohol, this carbon-oxygen bond will break. Oxygen will gain once again this 2 electron, and it eliminate in the form of water. And here carbocation formation occur. Now here stability of tertiary carbocation is more, Therefore, elimination reaction easy with a tertiary alcohol, then after secondary alcohol, and then after primary alcohol, because stability of primary carbocation is less. Therefore, dehydration of tertiary alcohol is easy as compared to secondary, and secondary alcohol is easy as compared to primary. I hope you have understood. Now in third step, formation of alkene. Out of this 3 Ne hydrogen, 1 H plus ion will lost and carbon-carbon double bond form, and as a result we get a alkene. So from ethanol we have obtained ethane. Now I have given a question why we are not using hydrochloric acid or a nitric acid. Then hydrochloric acid and nitric acid will give us a nucleophile like either Cl minus ion or either it gives us a NO3 minus. So here on carbocation this nucleophile will attack and we get either alkyl halide or nitro product will be obtained. Instead of elimination reaction, substitution will occur. So here we are using either sulfuric acid or either phosphoric acid we are using as a catalyst. So here in this lecture we have discussed dehydration of alcohol, how this reaction will occur. I will give you, and second, different example of dehydration reaction which is necessary to study for a JEE and NEET. Now some miscellaneous example of dehydration reactions. We have studied mechanism. Now you have to apply, because in JEE it will be asked in a different way. Now here hydroxyl group means butane to all, secondary alcohol. Dehydration reaction occurs, then hydroxyl group at protonation occurs, water molecule eliminate, and as a result after elimination of water molecule we will get a secondary carbocation. Now here we obtain a secondary carbocation. Now in this secondary carbocation will be obtained to us. Now what will be the product? Then we have two different possibility. Either hydrogen atom eliminate from this carbon atom or either hydrogen atom eliminate from this carbon atom. So we have two different possibility. Suppose hydrogen atom eliminate from first carbon atom, then we get this type of product CH3 CH2 and here now CH double bond CH2, and name of this product is but1ene. And second possibility, suppose hydrogen atom remove from this carbon atom, then we get a CH3 CH double bond CH CH3, and probability of this product is but2ene. Then which product will be obtained? Then scientists known as the SETZEF have informed us that more substituted alkyl will be more stable product. So according to SETZEF rule, we will get this but2ene as a major product and this will be obtained as a minor product. So why we are getting but2ene as a major product? When according to SETZEF rule, he is informed that more substituted alkyl will be obtained. So here more substitutions with a double bond containing carbon is present in a but2ene. Here only one substitutions, here more means two alkyl substitution. So according to SETZEF rule, we will get a but2ene as a product. Now here 3-methyl butane 2-ol is given. This was already asked in your NEET exam. Now here protonation occurs, you know very well mechanism, and it will eliminate in the form of water molecules. So we get here carbocation. Now formation of carbocation occurs. Now here you observe that this is a secondary carbocation. This is nothing but a secondary carbocation. So it is observed that, or we have studied, stability of tertiary carbocation is more as compared to secondary, and secondary more stable as compared to primary. So we have already studied that tertiary carbocation is more stable as compared to secondary, and secondary carbocation is more stable as compared to primary. So now here, in order to obtain stability, from this carbon atom, this hydrogen with electron pair will shift on a neighbor carbon atom. So this thing is a hydride shift occurs. So we will write it here, hydride shift occur, and because of this hydride shift, we will get a tertiary carbocation. So we get this structure CH3C, CH3, and here once again CH2, CH3, and here we obtain this carbocation is a tertiary carbocation. Now you know very well in tertiary carbocation we have a two different product, one will be major and second will be minor. Suppose hydrogen atom remove from this carbon atom, then double bond form between these two. So as a result we get this structure CH3, C, double bond CH, CH3 here and here CH3. So we have obtained this product which is known as a 2-methyl, but-2-ene. We have obtained product 2-methyl but-2-ene. Now here suppose hydrogen remove from this carbon atom, then we get this product CH2 double bond C, CH3, and we get here CH2, CH3. So this is the name of this product you know well, 2-methyl but-1-ene. So which will be major product? Then according to Set-Zepf rule, more substituted alkyl will be more stable product. So according to Set-Zepf rules, this will be obtained as a major product and this will be obtained as a minor product. So you have to select what is the major and minor product. So if you are knowing mechanism, then you can solve this type of example very easily. Now here this example. Now here name of this product we can give that 2,2-dimethyl cyclohexanone. Name of this product is 2,2-dimethyl cyclohexanol. Now this 2,2-dimethyl cyclohexanol, here protonation occurs and as a result we get this carbocation. Now here this 2-methyl group as it is and we have obtained carbocation on this carbon. Now here this is a secondary carbocation. So in order to obtain stability here, this methyl group with electron pair, shift on this carbon atom. So here we can write that methyl shift occurs. It is observed that here methyl shift takes place. Now when methyl shift takes place, we get this tertiary carbocation. Now here methyl group, here methyl, and here positive charge. So now here observe that here this carbocation is a secondary carbocation. Stability of tertiary carbocation is more. So in order to obtain stability, this methyl group with electron pair transfer. So here methyl shift occurs and as a result now tertiary carbocation formation occurs. Now here in tertiary carbocation, hydrogen atom removed from this neighbor carbon atom. So we get a maximum substitution and as a result we get this product as a alkene. So name of this product you can give 1,2-dimethyl cyclohex-1-ene. We can write name of this product 1,2-dimethyl cyclohex-1-ene. 1,2-dimethyl cyclohex-1-ene will be obtained. So here we have studied exceptional example of dehydration reactions. So lot of example this type of given you have to study to get a mastery. Dear students, don't forget to like, share and subscribe our channel. See you in next lecture.